Welcome back to my channel. In today's video, we discuss the synthetic methods in organic chemistry, in which in this series we discuss the different cyclization reaction. Before that, a very important topic is Baldwin's rule. The Baldwin's rule, which is discovered by J.E. Baldwin in 1976. Okay, this rule very important for ring closing reaction. Okay, now let's see some point. Baldwin rule only applicable for ring closure reaction. Second point, he suggested which ring closure reaction is favorable or disfavorable. Okay, Baldwin suggested that which ring closure reaction is favorable or disfavorable, under the which condition will be applied for the favorable condition. Now third point is, it is non applicable for pericyclic reaction and second row element. Okay, from above this is one thing is, always remember your Baldwin's rule only applicable for ring closure reaction and which is not applicable in pericyclic reaction. When you reaction carried out in pericyclic session or pericyclic reaction, at that time Baldwin's rule not applicable. Okay. Before that, we discussed the rate of formation of saturated ring reaction. Okay, any idea which ring will be formed fast? Rate of formation of saturated ring. Okay, in which your 5-member ring is rate of formation reaction is very fast as compared to your 6. Then after 3, then 7, and lastly is 8 to 10. Sorry. After the 7, here 4, then lastly 8 to 10. In this order, the rate of formation of saturated ring, 5-member ring, is very fast. Okay, here very fastest rate. Here it is very slowest rate in which ring formation. Okay, now we discussed the Baldwin's rule, which suggested 3 point. Okay, shall I rub this? in Baldwin's rule that suggested second point whether the bond break, that is, as the ring formation reaction is inside. If your bond breaking is inside, then we call as endo. If your bond break outside the ring or is called exo of the new ring. It means whether the bond breaks, that is the inside of the formation of ring or outside of the formation of ring of a new ring. Then we call as endo exo. If your bond breaking take place inside the ring, in which is formation new ring, at that time we call as endo. If the the bond break outside the ring, we call as a exo. And third point is electrophilic or electrophile. Whether whether the electrophile is sp, sp2 or sp3 hybridization. Okay. Three things are very important according to Baldwin's rule in the ring closure reaction. First, how many number of the ring will be formed? What will be the reaction take place? Means bond break, exo or endo. If your bond break outside the ring, we call as a exo. If the bond break outside the ring, it's called exo. If the bond is break inside the ring, when we call as a endo exo process. And third, whether the electrophile is sp, sp2 or sp3 hybridization. Okay, let's see the nomenclature. Shall I rub this? After that, nomenclature in Baldwin's rule according to the Baldwin's rule. In nomenclature, you know that your sp3 hybridization showing tetrahedral geometry. Everyone know about that tetrahedral geometry. If your hybridization is sp2 hybridization, then the geometry is trigonal. If your hybridization is sp, then geometry is diagonal. They focus on not geometry. Here only nomenclature is mentioned. From this we use take for if your hybridization electrophile hybridization sp3, at that time we use take. If your electrophile is sp2 hybridization, we can use trig. Okay. If your hybridization is sp hybridization, we can use dig. Okay. Take, trig and dig. Okay. The next point, Now we discuss the endo or exocyclization. In first we discuss the endocyclization process. When the bond breaking process is carried out within ring or inside the ring, which is the ring form, where bond breaking to the ring is inside the ring. When the bond breaking to the ring is inside, then endocyclization. Let's see the example. Here, okay. Now, what will be the get? This is our endo product, because here double bond is break inside the ring formation. Okay. After that, we discuss exocyclization. Exocyclization means when the breaking of the bond outside in the ring, outside to the ring, is called exocyclization, where the bond breaking is outside to the ring is called exocyclization reaction. Okay, let's see the reaction. This will be attack here and formation of ring, and this bond will be break outside that particular ring. Okay, we call as exocyclization. Got it? Or confused in endo or exo. We comparative discuss endo and exo. Okay, shall I rub this? When your cyclization takes place. Here we already mentioned endo and exocyclization. Okay, comparative. If your endo process, okay, look here, and here your exo process. What will be the product? The bond breaking reaction takes place. Okay, here it will be attack here, and this bond will be break inside the ring. Then formation of ring is, okay, and this X will be attack here and bond breaking take place. Then which is outside that ring. Here, bond breaking is inside the ring. Okay? Now, we get this is outside. This is inside portion. Okay? We also showing here inside. Okay? Is called endo, is called exo. After that, nomenclature rule first will be discussed. In Baldwin's rule, first point is numerical prefix is indicate ring size. Okay? How many member ring will be formed? 3 member, 4 member, 5 member. Okay, numerical prefix is indicate ring size formation or ring form. Ring size form. Then, or we write here ring form size. Okay. Then, second point, the suffix which refers take, trick or dig. The suffix which refer tetrahedral geometry from this tet, trick or dig that refers which refer that electrophilic carbon or electrophile carbon geometry. Okay, we already discussed if your carbon is tetrahedral or sp3, electrophilic carbon or electrophile carbon is sp3 hybridization. We use tet because it is formed tetrahedral. If you are sp2 hybridization, then we use trig because geometry is trigonal plane. And if your sp hybridization, then we use diagonal geometry. We use dig. Now let's see the example. Okay, completed. When you are completed, then shall I have this and next example. How can nomenclature? Okay. Here, example mentioned. We numbering first. 1, 2, 3, 4, 5. Okay? And 6. Which will be 6. But here, lone pair, X having a lone pair is, and Y is any living group. Then ring formation take place. Okay? That attack on this carbon number 5 and Y is required. Formation product like that. X and Y. Okay? Then nomenclature. How many numbers of ring form? 1, 2, 3, 4, 5. Okay. Here bond breaking process is inside ring or outside ring? Inside or outside?
Outside.
Outside. Very good. So we explain here exo. Okay? But before exo, we know that how many members ring form here? 1, 2, 3, 4, 5. Therefore, 5 exo, this carbon geometry is sp3 or sp2 or sp. This here hybridization is sp3. Their geometry is tetrahedral. So we use tet. Okay? Got it? If your compound formation ring is 5 member, your numerical prefix here 5, and bond breaking process outside the ring which is newly formed here exo, and hybridization is sp3. So it is tet. Okay. Let's see the second example. Shall I rub this and after that? Similar reaction take place and tell me what will be the product form. Remember it here 1, 2, 3, 4, 5, 6. Okay, 6 member ring will be formed. Then
when you can group like under shifting select
but it will be defined.
naming group. Any
Now tell me what will be the name when your product will be formed. Okay. Here, formation of 6 member ring. One, two, three, 4, 5, and 6. Nomenclature is 6 exo tet. Okay. Now we discuss third example. Here, we first numbering 1, 2, 3, 4, 5, and 6. Tell me what will be the product form? Here, attack will be here. Then formation of how many ring? How many members ring is 6 member. Okay? 1, 2, 3, 4, 5, 6. So naming is
6 exo
6 hexo endo because attack here and then okay 6 endo tetra or trigonal or diagonal. Which hybridization of your 6 number carbon? sp3 hybridization. Okay, then we use tet. 6 endo tet. Okay, do you understand? Now we discuss the rules for ring closure for tetrahedral system. Okay, we we sequentially discuss for tetrahedral, then trigonal system, then diagonal system. Okay. here the rules for ring closure reaction for tetrahedral system. We already discussed how can ring formation reaction take place, how can nomenclature. Then after we coming back to for tetrahedral system. If your ring formation is 3 member to 7 member, exo, tet, all are a favorable process. We prepare before the that example. Okay, and if your formation form 5 to 6 member ring form, then endo tet are disfavorable. Lastly, we discussed the 6 endo tet that are a disfavorable reaction. The reaction take place or not? Not, because according to Baldwin's rule, it is a disfavorable reaction. Okay? Write down this very important point. After that, we draw the structure which are favorable. Okay? Here, we some example mention in tetrahedral system which is favorable process. Okay? We already see how can reaction is carried out. Okay? First, we numbering from this 1, 2, 3. 3-member ring is will be formed. Therefore, we call 3 exotate because bond break outside the ring. We show here product X. Okay, like that product will be formed. Then here also numbering 1, 2, 3, 4, 5. Here that bond will be break outside the ring. Here 4 exotate. Here also 1, 2, 3, 4, 5. 5-member ring form, 5 exotate. Because the hybridization of this carbon which involve electrophile as a electrophile is sp3 hybridization. Their geometry is tetrahedral. So we can use tet. Okay. In this example again numbering 1, 2, 3, 4, 5, 6. This attack on 6 number carbon, Y will be divided. Here 6 number carbon is geometry is sp3. So we use 6 exotate which is a favorable. Then here again numbering 1, 2, 3, 4, 5, 6. Okay, and 7. 7 members of ring will be formed. We showing the product or you can do here simply formation 3-member, formation of 4-member ring, 5-member ring, 6-member ring and 7-member ring. Okay. Now we discuss the disfavorable process. Okay. After we completed showing that particular product, what will be the product? We showing the first product. Now we discuss remaining products. Okay.
Killing this.
Now, here we discuss the tetrahedral system disfavorable process in which our formation product is 5 members. Okay, then nomenclature is 5 endo tet because electrophile is sp3 hybridization or their geometry is tetrahedral. Here 6 endo tet. Now we discuss trigonal system. After your completion, then we discuss trigonal system. Here it's a disfavored processes. Okay. Now we discuss the trigonal system in which 3 to 7 exotrit are a favorable process, and your 3 to 5 member ring which is endo, okay, which is endo trig are disfavored, but in which 6 to 7 endo trig are favored. Here mention 3 to 7 all exotrig are a favorable process, and 3 to 5, okay, which is endo-trig are disfavorable. But after 5 to 6, endo-trig system are favorable. Let's see their structure or reaction. Write down, write down this example which is favorable process in which our 3 exo trig is favorable. First we numbering 1, 2, 3. Okay. Here 3 numbering will be formed which is exo. Here that bond will be attack on this electrophilic carbon which nature is sp2. Therefore we use trig. What will be the product? X, remember ring and Y. Okay? You can show all these product 1, 2, 3, 4. 4 member ring and your geometry of this electrophilic carbon is sp2 which is sp2 hybridization and geometry is trigonal. Therefore we use 4 exo trig. Similarly here also 1, 2, 3, 4, 5. Okay, 5 exo trig, 6 exo trig. You can show that all these reaction and product and select. Okay. All product are exocyte or exocyclization take place. After that we discuss the endosystem, okay, which is disfavorable and favorable process. In trigonal system, endo, disfavor and favorable process here discuss. Okay, if your X will be attacked on this sp2 hybridized carbon which is electrophilic nature and formation of ring is 3 member 3 endo trig. Okay, name is 3 endo trig. Now here also four endo trig. Here 5 endo trig. These are a disfavorable reaction. Their product you can show. Okay, and here 6 endo trig and 7 endo trig. Here attack will be here and formation of ring. Okay. You already write down that particular exosystem and endosystem. Your 3 to 5 endotrig system are disfavorable and 6 to 7 endo are favorable. Now we discuss third system is diagonal system. Now we discuss the trigonal system is endosystem which is disfavorable and which is favorable process. Here 3 endo trig is favorable because here 3 member ring is formation and electrophilic carbon is sp2 hybridization. Their geometry is trigonal. Therefore we use 3 endo trig. Okay, 4 endo trig, 5 endo trig which are disfavorable. You can show the product and favorable reaction is 6 endotric and 7 endotric. Okay. Now we discuss the diagonal system.
Madam, first
Now we discuss the diagonal system in which 3 to 4 exotic are disfavorable process and 5 to 7 member in exodic are favorable process, in which 3 to 7 endodic are favorable process. Let's see their system. Now, this diagonal system, there 3, 4 exodic are disfavorable. Here, attack on this carbon, which is sp hybridization, and their geometry is diagonal. So we can use dig, 3 exo dig. Okay, 4 exo dig. There are disfavorable, and your 5 exo dig, 6 exo dig, and 7 exo dig are favorable process. Okay, this is your exosystem. Now we discuss our endosystem. You can show that product. This X will be attack on this carbon triple bond and formation here a ring size. Then bond breaking process is outside of the ring. Okay. Now we numbering in this 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7. 7 exo D. Okay. Now we discuss the endosystem. In diagonal system, 3 to 7 endo-dig are favorable. Here, formation reaction is inside the bond breaking process. So, we numbering 3 endo. This carbon hybridization is sp hybridization, and their geometry is diagonal. So, we use dig, 3 endo dig, 4 endo dig, here 5 endo dig, 6 endo dig, and lastly 7 endo dig. Okay, these all our system are favored according to Baldwin's rule. After that, we discuss some example in next lecture.